To examine what happens with reflections, we're going to start with the square root of x. This starts at the origin, and remember it's like half a parabola on its side is the shape. The square root graph or the square root function is undefined for negative values. If you try to take the square root of -9, for example, it's not a real number. Because when we square numbers, we always get positive results, or at least non-negative results, which means that it's not possible to back this process up when we're going the other direction. So these 4 points are on the graph of the square root function. We're going to look at, first of all, y equals minus the square root of x. And let's go ahead and move down a little to give ourselves some space here. Minus the square root of -9 is still undefined, right? Having that minus on the outside doesn't really change anything, so we have the same issue here for all of the negative values of x. The function is still undefined for all of these. Negative square root of 0 is still 0. Negative square root of 1 is going to be -1, since I would take the square root of 1 first and then apply the negative. Negative square root of 4 is going to be -2, and negative square root of 9, -3. So when I plot these 4 points, or the ones that will fit anyway, on my grid, I have the origin and 1, -1, 4, -2, and 9, -3 would be further out. This is what my graph looks like. And I just darkened in these axes because I noticed as I was starting to graph this that they didn't come through very well. All right, so from our original graph, we can see that it looks like it flipped over, right? And this graph is what we would call reflected about the x-axis. It's kind of like a rotisserie chicken, right? The x-axis is the spit, and the graph is the chicken that's turning about the spit. It just turned until it was exactly below, and that's how we get our reflection. So next we're going to see what happens when that minus sign, instead of being outside of the square root, is inside the square root and applies directly to the x variable. So based on our data that we already have for y equals the square root of x, we're going to look at y equals the square root of minus x. This time I have x is -9 and y is the square root of the opposite of -9. Because the minus sign is inside the square root this time, they do cancel each other out in a sense, right? The opposite of a negative is positive. And so this one is defined. This is 3. The same thing happens with all of the negatives. This becomes 2, this one becomes 1, and of course the square root of the opposite of 0 is the same thing as the square root of 0, which is just 0. And now it's the positive x values that start giving us trouble. The minus comes from our function, and when I plug in 1, I can see that I get something that is not real. So this issue is going to occur now with all of my positive x values. And we'll come up here and plot the points that we have. -4, 2, -1, 1, and 0, 0. With -9, 3 being off the chart, we will leave that one off. What we see in these data and in this graph, comparing it to our original graph here again, is that the graph appears to be reflected now about the y-axis. So when the minus sign applies directly to the x variable, the movement is again more in the x direction, which turns out to be a reflection about the y-axis. And so we could summarize these reflections in that way. This minus sign is applied directly to x. When the minus sign is applied directly to x, we see our reflection about the y-axis. When the minus sign is outside and applies directly to the whole function, that's when we get our reflection about the x-axis. That's like changing the signs of all the y values instead of changing the signs of all the x values. So we can now look at an example that combines a reflection with a shift. We have two transformations here. One of them is the minus sign, which is outside of the base function. The base function that we're comparing this to, by the way, is y equals x squared. The subtracting of 5 and the minus sign out front are both transformations. But squaring isn't a transformation. The square is what identifies the function that we start with. That's a parabola. So this minus sign outside is a reflection because it is not attached directly to the x variable. It's instead outside. This is a reflection about the x-axis. And the reflections about the x-axis are a bit more common than they are about the y-axis. The reason for that is that a lot of the graphs that we start out learning to graph by transformations are symmetric about the y-axis anyway, and so reflections about the y-axis just aren't very interesting. Subtracting 5. Note that the 5 is subtracted directly from the x variable. It's not subtracted from the outside after squaring. That's how we know it's a horizontal shift. And having identified this as a horizontal shift, we then know that this is the kind that goes in the sort of counterintuitive direction. It's a subtraction of a number, and yet it goes in the positive direction, and therefore it must be a shift right 5. So remembering first of all what the base function y equals x squared looks like, I'll do that in a very light blue that's kind of hard to see so that it doesn't distract from our final graph. I'm starting from this parabola. I want to reflect about the x-axis, which will make the parabola open down. And I want to shift it right 5, which is going to move the x-intercept from the origin to 5, 0. So I'm going to redraw my parabola shape now here, going down instead of up, but drawing in all of the points that are on the graph of a parabola relative to my vertex, not relative to the origin. And I get my transformed graph.